Hello my dear students, welcome to mathematics classes for 9th class. This is chapter number 8 quadrilaterals and we are doing part 4 in which we are going to learn about midpoint theorem and the converse of midpoint theorem, and on the basis of that then we will solve exercise 8.2 of NCERT. So let's start the video with your Jerry sir. So students, today we are going to start our part 4 of chapter number 8, that is quadrilateral, and today we are going to learn about very important theorem, that is midpoint theorem. So what is midpoint theorem? The line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half of it. Let's see the figure. The figure is given triangle ABC in which line segment DE. This DE line segment is made from the midpoints of side AB. As you can see here, D is the midpoint of AB. Therefore, BD is equals to AD. And the same way, E is the midpoint of AC. Therefore, CE is equals to AE. Okay, this part is equal to this part, and this part is equal to this part. Now, DE is the line segment which joining these two midpoints. So when something happen like this, when the line segment joining the midpoints of a triangle, so it will be line parallel to the third side, that is BC. So DE will be parallel to BC, and this DE will be also what? Half of BC. Okay, if it is 8 centimeter, then DE will be 4 centimeter. If it is 10 centimeter BC, then it will be 5 centimeter. This is what? Midpoint theorem. Okay, now we can prove this theorem also. Just check here. What is given to us in triangle ABC? D is the midpoint of side AB. A triangle ABC is given in which D is the midpoint of side AB and E is the midpoint of side AC. Now we have joined DE. Okay, so we got a line segment DE. Now what we have to prove? We have to prove that DE is parallel to BC and DE is what? Half of BC. It means we are proving midpoint theorem. So we have to do some construction. As we have done construction, what? We have produced this DE line to F, or we can say we have extended DE line to till F point. Okay, and then we have joined this DE. Okay, in this way that this DE becomes equals to EF. Okay, in this way we have done this construction, and at last we have joined this F point to C point with this line. Okay, so we got that one more triangle here. Now we have to prove that this DE is parallel to BC, and we have to prove that this DE is also what? Half of BC. So let's prove. We have taken two triangles. As you can see here, two triangles, triangle AED and triangle CEF. These two triangles we can see here. Now we are trying to prove these two triangles what? Congruent. Only then we can prove that some parts of this triangle is equals to that other part by CPCT. So let's see. In triangle AED and triangle CEF, or you can say FEC, same thing. Here AE is equals to CE. What I am saying here, AE is equals to CE. Why these things are equal? Because we can say that it was already given that E is the midpoint of AC. That's why AE will be equals to CE. Okay, and we said D is the midpoint of side AB. Therefore, this part is also what? Equals to this part. Okay, AD will be equals to BD. So right now we are saying that AE equals to CE. We are taking this part only. AE equal to CE because we don't need this line. So we need this triangle and this triangle. That's why we are taking AE and CE. So we said AE equals to CE as it was given in the question. Then we are saying angle AED, it means this angle, and angle CEF, it means this angle. These two angles are vertically opposite angles. Just focus here. As you can see here, these two angles are vertically opposite angles. Okay, so we have written AED equals to angle CEF, vertically opposite angles. At last we are saying ED equals to EF. ED equals to EF, as we have proved it by construction. We have said it in construction only that these two sides are equal. Therefore, three things we have proved. So by side, angle, side, it means by SAS, we can say that this triangle AED is congruent to triangle CEF. And if these two triangles are congruent, so their corresponding parts will be equal. So we are saying that AD is equals to CF. This side AD is equals to CF by CPCT. And we can say ADE. This angle is equals to CFE, it means this angle. This is also by CPCT. So both things we have proved by CPCT. Okay, now move to next part so that we can prove this thing. So as we can see, just we said that AD equals to CF by CPCT. These two are equal. We have written equation 1 also. Now AD is also equals to DB, as D is the midpoint of AB. It was already given. Therefore, as you can see here, AD and AD common is cut. What left? CF is equals to DB. So we can say DB is equals to FC or CF, anything you can. So we said DB is equals to FC. This is our equation number 2. And BD is parallel to CF. This BD is parallel to CF, this line, by construction. So these lines are equal also and parallel also. So what it means? It means if in a quadrilateral, if opposite sides are parallel and equal, so we can say that that quadrilateral is what? A parallelogram. So BCFD is a parallelogram. Okay. Therefore, if it is a parallelogram, so we can say this DF is also parallel to BC and DF is equals to BC. So we said DF is parallel to BC and DF is equals to BC. Okay. And now if these two parts are, these two lines, DF is parallel to BC. So therefore, we can say DE is also what? Parallel to BC, because DE is the part of DF only. Just check here in the figure. This DE is the part of this DF only. If DF is parallel to BC, therefore DE is also parallel to BC. And in this way, we have proved our first part. So DE is parallel to BC, proved part 1. Part 2, we have to prove that this DE is half of this BC. So now just check here. DE is already what? Half of DF. Why? Because this DE is equals to EF by construction only. These two lines are equal. So we can say as DE is half of DF, or we can say EF is the half of DF, but we need DE, so we are saying okay, DE is half of DF. Now DF is equals to what? BC. DF is equals to BC. Just check here. DF is equals to BC. So in place of DF, I am writing BC. So DE is become half of BC, and this thing only we have to prove. So we have proved that DE is parallel to BC and DE is half of BC, and this is the only thing which is said by midpoint theorem. So in this way we have proved our midpoint theorem. Now students, we will going to learn about the converse of midpoint theorem. Okay, just opposite. What is given in that midpoint theorem, that thing we have to prove now. So the line drawn through the midpoint of one side of a triangle parallel to another side and bisects the third side. Bisect means dividing in equal parts. So as you can see here in triangle ABC, this theorem also we will prove, converse of midpoint theorem. So in triangle ABC, as you can see here, D is the midpoint. D is the midpoint of AB. Therefore, if it is midpoint, so this side is equal to this side. It means AD equals to BD. And DE is parallel to BC. DE is parallel to BC. This and these two sides are parallel to each other. Now what we have to prove? We have to prove that this E is the midpoint of AC. E is the midpoint of AC. Okay, this is only converse of midpoint theorem, and this thing only we have to prove. We have to prove that if a line segment drawn through the midpoint of one side of a triangle parallel to this side BC and what? Bisect the third side. It means this E point, this DE line is bisecting this AC. So it means E is the midpoint. If we prove this E is the midpoint of this AC, so we can prove this theorem, converse of midpoint theorem. So we have done some little construction, that we have drawn CF which is parallel to BD, or you can say BA. CF we have done construction, we can increase more, which is parallel to BA. Okay, and then we have extend this E to point F, till point F we have constructed it. Okay, now we have BD which is parallel to CF. What we are having? We are having BD parallel to CF, BD parallel to CF. Okay, why? Because as BA is parallel to CF, therefore BD is a part of AB only. Therefore BD is also parallel to CF. Okay, now DF, just check, DF is parallel to BC. Why? Because DE is parallel to BC. It was already given. Just check here. DE is parallel to BC, DE. So just we are extending it more. So DF is also parallel to BC. Okay, now if these two sides are parallel, BD is also parallel to FC, or you can CF, and here DF also parallel to BC. If the opposite sides of a parallelogram are parallel, so it will be if the opposite sides of a quadrilaterals are parallel, so we can say that the given figure is what? Parallelogram. Therefore DFCB is a parallelogram. If it is a parallelogram, so opposite sides will be equal also. Just check here. CF is equals to BD. CF equals to BD. Okay, and BD, this BD is equals to AD. Why this BD is equals to AD? As it was already given that D is the midpoint. Okay, so these three becomes equals to each other. CF equals to BD and BD equals to AD, as this is the midpoint of AB. And this is our equation number 1. Now just check triangle ADE and CFE. ADE and CFE. This triangle and this triangle. Just pay attention on these two triangles. Okay, these two triangles. So in triangle ADE and triangle CFE, angle EAD is equals to angle ECF. Just check EAD. It means this angle they're talking about. This angle. This angle EAD is equals to angle what? ECF. It means this angle. Why? Just pay attention here. Just check here. This AB is parallel to CF. AB is parallel to CF. Okay, AB is parallel to CF. And this AC is working as a transversal. So what will happen? This angle and this angle will be equal or not? Definitely they are equal, as they are making pair of alternate interior angles. So we can say by alternate interior angles, EAD is equals to ECF. And AD equals to CF. AD is equals to CF. Why? Because we have proved this thing in equation first. Just check here. Equation first. Okay. So AD is equals to what? CF. This AD is equal to CF also and BD. So we are just taking these two. AD is equals to CF. Okay. AD is equal to CF. These are two parts of these two triangles. And last we are saying ADE. This ADE. This part is, this angle is also equals to what? This angle is equal to this angle. Why? Same reason, parallel lines. So these are now this time this DEF is working as a transversal. This and this angle will be equal. So this is also by alternate interior angles. So by angle side angle ASA, we are saying that triangle AD is congruent to triangle CFE, and these two triangles are congruent, therefore their corresponding parts will be equal. So we are saying AE is equals to CE. Okay, because we have proved these two triangles are, this and this triangles are congruent, therefore AE is equals to CE by CPCT, and if these two sides are equal, so we can say yes, E is the midpoint of AC. And here we have proved our theorem, that is converse of midpoint theorem. So here it is completed. Now on the basis of our midpoint theorem and converse of midpoint theorem, we are going to solve the questions of exercise 8.2 NCERT book, in which first question is given. As you can see, ABCD is a parallelogram. ABCD is a parallelogram in which P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of DC, and S is the midpoint of AD, and this AC is a diagonal. Then we have to show these parts. So let's solve this question in our copy. So as you can see, I have drawn the figure of question number 1 in our copy. We have written the given parts, okay, and what we have to prove, first, second, third, I have written here. In the first part, we have to prove that this SR is parallel to this AC. SR is parallel to AC, and we have to prove this SR is also half of this AC. Now this thing reminds us about midpoint theorem. Okay, so in triangle ACD, what we are taking, triangle ACD. Okay, if we prove that this S and R is a midpoint and this line segment is joining these two midpoints, so we can easily say by midpoint theorem this is half of AC and this is parallel to AC. Okay, so let's see. In triangle ACD, S is the midpoint of AD. S is the midpoint of this AD. It was already given in the question, okay, starting. And it is also given that R is the midpoint of DC. Okay, and this SR is the line segment with joining these two midpoints. And we know that if a line segment is there with joining the two midpoints, so it will be what? Through the midpoint theorem, it should be parallel to the third side, that is AC. We're talking about this triangle ADC. So it will be, this SR will be parallel to AC and it will be half of also AC through midpoint theorem. So in this way we have proved our first part. In second part they are saying that prove that PQ is equals to SR. This PQ is equals to SR we have to prove. Now in triangle ABC, downward triangle ABC, okay, ABC, P is the midpoint of AB and Q is the midpoint of BC. Again, PQ is a what? Line segment with joining the two midpoint. Therefore, PQ will be parallel to AC and PQ will be half of AC. Again, by midpoint theorem only. Again, by midpoint theorem, PQ is parallel to AC and PQ is half of AC. Now just pay attention. PQ is also half of AC and SR is also half of AC. So both are equals to half of AC. So half of AC cut. What left? SR and PQ. It means by equation 1 and equation 2, PQ is equals to SR. Clear? Because both are equals to half of AC. Okay. So equals to equals are also equal. Now third part, we have to prove that PQRS is a parallelogram. This inside figure PQRS, we have to prove this figure is quadrilateral is what? A parallelogram. For a parallelogram, the sides needs to be equal and parallel. Let's check here. As SR is parallel to AC, SR is parallel to AC, we have proved in part first only, and PQ is also parallel to AC. This thing we have proved in second part. Just check here. PQ is parallel to AC in second part, and SR is parallel to AC, we have proved in first part. Therefore, if these two parallel to AC, again AC common, so what left? SR and PQ. Again PQ is parallel to SR, therefore PQ is parallel to SR, and PQ is also equal to SR because just we have proved. So PQ line is parallel also SR, and PQ line is also equal to SR. Just check. PQ line is parallel to SR, and these two lines are equal also. So we know that if in a quadrilateral the opposite sides are parallel and equal, then that figure, that quadrilateral will be called a parallelogram. Therefore PQRS is a parallelogram. So in this way we have done all the parts of our question number 1. So in this way you can try the other questions also of this exercise till question number 4. So let's do the other questions by yourself. At last, I just want to say be safe and God bless you all.